Hello class, we're about to start lesson 7, probability. Simple probability. Probability tells whether something is likely or unlikely to happen. The probability of any event can be expressed by a number from 0 to 1. If an event has 0 probability, the event is impossible. An event with a probability of 1 is certain to happen. Most events are somewhere in between. To find the probability of a simple random event, we must identify favorable and possible outcomes. A favorable outcome is the event that we are interested in. The possible outcomes are all the possible events that could occur. Theoretical probability, sometimes called simple probability, is the ratio of favorable outcomes to possible outcomes. The spinner is divided into 8 equal sections. What is the probability of spinning a 4 on the spinner? Now, if you notice here, we have 1 1, 2 2s. Well, we had 2 4s here. So it's 8 spaces that this pointer can go. It says there are 2 sections labeled 4 on the spinner. There are 8 sections in all. Use the probability ratio, favorable outcome divided by possible outcome. So favorable outcome is 2 favorable outcomes getting a 4. So it's 2 out of the total, or the possible outcomes, which would be 8. So it'd be 2 out of 8, which we simplify to 1/4. The probability of spinning a 4 on the spinner is 1 out of 4, 1/4, 0.25, or 25%. Now, what I want to do really quick here, I want to show this to you in the calculator as well. Say you got the 2/8. So we do 2 divided, well, let me clear this out. Press N over D, then 2, down arrow 8, and then press enter. It gives you the simplified fraction. So let's just say that they wanted to answer as a fraction. Just putting in the fraction and press enter will give you the simplified fraction. Now let's say they wanted a decimal. So we could do N over D, we'll do 2, bottom arrow 8, and then a right arrow. Then we'll press second, and then this table key. So it goes fraction to decimal, press enter. So that gives you the 0.25. Now the next thing is they have percent. So now we go press N over D. We'll press 2, down arrow 8, the right arrow, then we'll press second, and then the right parenthesis, and press enter. So that gives us all of the different types of answers. We got percent, we got decimal, and we have the fraction. So this is how you would do this in the calculator. Okay, now, it says here in example 1, probability was based on what we knew could happen. Another type of probability called experimental probability is based on what actually happens during the trials of an experiment. The number of trials are the number of times you try the experiment. So now example 2, Ricardo and Scott used the same spinner to play a game. They kept track of the numbers that they got on each spin for 20 spins. The numbers are shown below. Based on their results, what is the experimental probability of spinning a 4? So Ricardo and Scott spun a 4 6 times out of 20. So we look here, we got 1, 2, 3, 4, 5, 6 times out of 20. Because they told us that they did it for 20 spins. So it says use the ratio. It's favorable outcomes divided by number of trials in experiment. So the only difference between the simple probability and the experimental probability is the denominator is saying the number of trials in experiment instead of possible outcomes. But it means the same. There were 20 outcomes from spinning that spinner. So that is your denominator here. So now we have 6 over 20, which is 3/10, 0.3 or 30%. Now I just showed you all how to do this in your calculator. So if you want to go back and look at that, you can rewind this video and take a look at how they would get these 3 values. Now notice that experimental probability is close to, but not necessarily equal to, theoretical probability. Theoretical probability can tell you what will probably happen, but it can't predict what will actually happen. So we go here to the next page, 7.1. It says express probability as a fraction, decimal, and percent for questions 1 through 5. Do not use a calculator. Now they're telling us not to use a calculator, so we have to do everything by hand for problems 1 through 5. Okay, now it says a game has 50 wooden tiles. Players draw tiles to spell words. If 20 of the tiles are marked with vowels, what is the probability of drawing a vowel from the tiles? Okay, now we did not say that they actually did this, so we're going to do a simple probability. Now, if we go back up here with the simple probability, it's the favorable outcomes divided by the possible outcomes. So, what we have here, and this is problem number 1, we have the favorable, so we have probability is equal to favorable outcomes divided by possible outcomes. So, the favorable outcome, they want us to say, it says here, if 20 of the tiles are marked with vowels, what is the probability of drawing a vowel from the tiles? So the favorable outcome would be the vowels, and there's 20 of them. So 20 would be your favorable outcome. Now, let me see if I can make this a little bigger. Yeah, that's good. So 20 would be your favorable outcome. Now we want to do the possible outcomes, which would be 50. So it'll be 20 over 50. Now again, we cannot use a calculator, but we know 20 over 50, we could divide both by 10, and that would give us 2/5. So that would be our fraction. Now they tell us to write a fraction, decimal, and a percent. Okay, so our fraction is 2/5. Now we're going to go down here and do our decimal. I'm going to block this off here. So the decimal, we would take 5 into 2.0. Bring up our decimal. 5 goes into 2 0 times. So 0 times 5 is 0. But 5 goes into 20 4 times. 4 times 5 is 20, no remainder. So our decimal is 0.4. So we have our fraction of 2/5. Our decimal is 0.4. Now our percent is a little easier because since we have our decimal, we know all we have to do to get our percent is to take the decimal and move it 2 places to the right, and that will give us 40 and put a percent sign behind it. So we had 2/5, 0.4, and 40%. All 3 of these are the answers for problem number 1. All right, now, for problem number 2, it says a spinner has 5 equal sections colored either red, white, or blue. After 40 spins, a player has the following results. So we know this is experimental probability. So if we look back at experimental probability, that's favorable outcomes over number of trials and experiments. Okay, so it says, what is the experimental probability of not spinning blue on the spinner? Okay, so now they did 40 spins, so that's the total amount of let me see how they worded it, number of trials in the experiment. I got to get used to this too, because I'm used to saying total amount of outcomes. So it's number of trials in the experiment. So since you did 40, that would be your denominator. So problem number 2, you have the probability your denominator would be 40. Now for your numerator, it says, what is the experimental probability of not spinning blue on the spinner? So what we would do is take out blue. So blue is 5, 10, 15, 20, 25 is 28. So to get our numerator, we'll take 40 minus 28 because we want not blue. So 40 minus 28 is 12 over 40. Now, when you have 12 over 40, 12 and 40 both has 4 in common. So that would give us 3 over 10. So 3/10 would be your fraction. So now, since we had 3/10, now we want to write that as a decimal. So we could take 10 into 3.0, bring up our decimal. 10 goes into 30 times, 10 goes into 33 times. And you had no remainder. So your decimal would be 0.3. So we had 3/10 as our fraction. The decimal would be 0.3. And now we have to change this decimal to a percent. So we'll take 0.3, move this decimal 2 places to the right, and that will give us 30%. So these are our answers: 3/10, 0.3, and 30%. Okay, now that took care of problem number 2. Now we move on to problem 3. It says there are 4 red, 4 blue, and 2 green marbles in a bag. So they're telling you there's a total of 10 marbles in a bag when you add them up. If one marble is chosen at random from the bag, what is the probability that the marble will be green? Now this right here is a simple probability. So we go here to number 3. So number 3, now we know the probability, we'll do the favorable outcome. It says if one marble is chosen at random for the bag, what is the probability that the marble will be green? So green marbles are the favorable outcome, and it's 2 of them. And the total amount of possible outcomes here is 10, because it's 4 red, 4 blue, and 2 green. So it's 2 over 10. So we can simplify that by dividing both by 2, and that would give us 1/5. So 1/5 is our fraction. Now we want to get our decimal. So we would take 5 into 1.0, bring up our decimal. 5 goes into 1 0 times. 5 goes into 10 twice. 2 times 5 is 10, there's no remainder. So your answer here would be 0.2. Now, to get the percent, so we have probability 0.2. We move that decimal 2 places to the right. So that would give us 20%. So that is our final answer for problem number 3. Now we go here to problem number 4. It says a movie theater sells 180 adult tickets and 60 children tickets to a movie. So they sold a total of 240 tickets when you add the 180 and the 60. As part of a special promotion, one ticket will be chosen at random, and the winner will receive a prize. What is the probability that the winner will be a child? Okay, so now they want the probability that the winner would be a child. So this is what we would do. So we know that our favorable outcome would be a child, which is 60 tickets. And then it would be divided by the number of, wait a minute, let me see that again, number of trials in an experiment. So I may have to change how I do that. So number of trials in the experiment, which here would be 240. All right, now, so we have 60 over 240, and we need to simplify this. So we could divide both of these by 10 first, and that would give us 6 over 24. And then 6 and 24 both have 6 in common, so that would give us 1/4. So 1/4 is our fraction. Now we have to do our decimal. So we would take 4 into 1 we'll make that 1.00. Bring up our decimal. 4 goes into 1 0 times. 4 goes into 10 twice. 2 times 4 is 8, and 10 minus 8 is 2. We'll bring down our 0. 4 goes into 25 times. 5 times 4 is 20, no remainder. So our decimal would be 0.25. Now that took care of our fraction, that took care of our decimal. Now we want to change this to a percent. So we have P is equal to 0.25, move that decimal 2 places to the right, and it will give us 25%. And that is it for problem number 4. Now, we go here to problem 5. It says a spinner has 6 equal sections numbered from 1 to 6. What is the probability of spinning either a 5 or a 6? So, again, they're numbered 1 to 6. So, basically, they say either a 5 or a 6. Okay, so now, we're going to take that. So that means that it's a probability of getting 2 different type of answers here. So, first of all, favorable outcome. We know that to get a 5, that'll be 1 out of 6. To get a 6, it'll be 1 out of 6. So it'll be 1 out of 6 for the 5 and 1 out of 6 for the 6. So that would give us 2 out of 6. Now we divide both by 2, and that'll be 1/3. 1/3 would be your fraction. Now, they want us to write this as a fraction, a decimal, and a percent. So 1/3, so we'll take 3 into 1 point, let's do 0, 0. 3 goes into 1 0 times, 3 goes into 10 3 times. 3 times 3 is 9. 1 will bring down our 0. 3 goes into 10 3 times. Subtract 9, that'll be 1. So we'll keep repeating these 3's. So our decimal here would just be, the probability would be 0.3 with the repeat decimal, because they did not ask us to round. So that would be our decimal. Now with our percent, now we've done this before. So 0.33 is our decimal. Our percent, now we know that 1/3 from our previous lessons is 33 1/3%. Now if you want to, you can look back at previous videos we've covered, but 1/3 written as a percent is 33 1/3%. So make sure you mark that down. Okay, so now that took care of problem number 5. Now, problem 6 through 8, we can actually use the calculator. It says choose the one best answer to each question. You may use your calculator. Questions 6 and 7 refer to the following information. A deck of 12 cards is marked with the following symbols. Now you notice here we have 1, 2, 3, 4, 5 diamonds. No, 6 diamonds. We have 6 diamonds, 3 clubs, 2 spades, and a heart. So we have a total of 12 cards here. If a card is chosen at random, what is the probability of selecting a diamond? So if you notice here, we're using a percent. So with number 6, we know that this is a simple probability. So favorable outcome, our favorable outcome here with diamond, we have 2, 4, we have 6 diamonds. It's 6, and it's out of 12 cards. So our fraction here is 6/12. So what we could do, if we don't know that offhand, we could go to our calculator, press N over D, press 6, down arrow 12, press the right arrow, press 6, second, and press the right parenthesis key, and press enter. So that would be, the probability would be 50%, which in this case would be C. So that's number 6. Number 7, it says, if a card is chosen at random, what is the probability of selecting something other than a club? So basically, they want the probability of everything but a club. So with number 7, let's see, how many clubs we had? We had 3 clubs. So the probability of the favorable outcome would be 12 minus 3, because we're subtracting out the amount of clubs out of 12, as we know it's 12 possible selections here. So 12 minus 3 is 9, so we have 9/12. So now we could take our calculator And you notice here they only have this in a fraction. So we'll take our calculator, clear this out, press N over D. We'll take 9, hit the down arrow, 12, and press enter. And that will give us the simplified fraction, which is 3/4, which is A. Okay, now, number 8. It says questions 8 and 9 refer to the following information. Aaron flipped a coin 40 times and made this table to show how many outcomes were heads and how many were tails. Based on Aaron's data, what is the experimental probability of getting tails on a coin flip? Okay, now, if you notice here, unlike the other problems we did, we actually have the out of. Now, just as a recap on the out of portion, when you do out of, that's just you taking a fraction and you see the fraction. The numerator would be in front of the word out, and the denominator would be behind the word of. So that's basically what it is. So if we were changing problem number 7 to an out of situation, we would do 3 out of 4, because 3 is in the numerator, 4 is in the denominator. So now we look here again at problem 8, and it says, let me see, getting tails on the coin flip. So basically we have 40 trials. So we know that our denominator is the number of trials in an experiment. So we had a probability equals the denominator is the number of trials in the experiment, and in this case, they told you that it's 40. So your numerator is the favorable outcome. We just want to get heads. No, we want to get tails, because it says getting tails on a coin flip. So we count how many tails we have. We have 5, 10, 15, 16. So we had 16 out of 40. So what we could do with our calculator is put in the 16 over 40. So we had 16 in the numerator, put 40 in our denominator, and press enter. And it gives us 2/5. So written out, that'll be 2 out of 5, which is, that's interesting. 2 out of 5, which would be D. All right, good. So we got problem number 8 taken care of. Now we look at number 9. It says, based on Aaron's data, what is the experimental probability of getting heads on a coin flip? So basically they want us to do the opposite, but this time with heads. So we would do number 9. The probability is equal to, now we know our denominator would be 40 because that is the number of trials in the experiment. Now our numerator, we would count how many heads it is. It's 5, 10, 15, 20, 24 heads. So now we had 24 over 40. So we'll put that in our calculator. We'll hit N over D. We'll hit 24, down arrow 40, and press enter. So simplified, that's 3/5. So this would be 3 over 5, and this would be 3 out of 5. So 3 out of 5 would be A. So now, we just finished the first part of lesson 7, chapter 4. So I'm about to record the second part, and I will upload this to YouTube. Have a wonderful day.